In this video, I'll be showing you how to simplify exponent expression with fraction exponent. So here is the first example on the screen right there. So what we're going to do is to deal with the numbers first. So you have a 2 times 2 times 3. So 2 times 2 times 3 is 12. So there's going to be a 12 as a coefficient. It's going to be a 12 as a coefficient. Now let's deal with the variables. Now you can see that the two of them have fraction variables, fraction exponents. So just like we dealt with whole number exponent, like if you have x to the power of 2 times x to the power of 7, you got it to be x to the power of 9 because you add them. Okay, the same way we're going to do here. We're going to add all the exponents together. So the first exponent is 3 over 2. We're going to add 3 over 2. We're going to add it to, so let's highlight them. We're going to add 3 over 2 to 2 and then to 5/3. So we're going to add it to 2, then plus 5/3. Okay. Now, it's better to get whole number also to have a denominator. I put 1. Now, this is a simple fraction addition, okay? So to do that, we need to get all the fractions to have the same denominator. I got to have these 2 to become the same denominator as all this. So the LCM of 2, 1, and 3 is 6. So everything should be 6th in the 6th. All right. Now, what do I need to do to 2 to make it become 6? That will multiply by 3. So I multiply by 3. Whatever I do to the bottom, I do to the top. This one by 6. This one by 2. So now we have 9 over 6, 12 over 6, and 10 over 6. Now they have the same denominator. I'm able to just add the numerators together. So 9 plus 12 is 21. 21 plus 10 is 31. So the whole fraction is 31 over 6. And I can see there's nothing that can go into both of them. So the coefficient is 12. Let's write it separately, probably on that column. So we have 12 as a coefficient. And the exponent is x to the power of 31. Excuse me. So 31 over 6. Let's get it together. 31 over 6. That is how you simplify that into one base. Okay, so that's the first example. Here is another example. In this case, you have r to the third power, to third power, to the power of 1/2. So now we need to remember that when it was whole number, we had something like r to the power of 2, r to the power of 3. What we did was we applied the second rule that says you apply the power to the power. So you apply this power to this power by multiplication. So that will be r to the 6th. All right. So we're going to do the same thing to this. So this will be r to 2/3 times 1/3. Okay. You're going to have to multiply them together. Now let's do the fraction multiplication over here. 2/3 times 1/3. 1/2. Sorry about that. This is 1/2. 1/2. Okay, so let's multiply it together. You will find that 2 times 1 is 2. 3 times 2 is 6. So it's 2 over 6, which you can reduce to 1/3. All right. So this expression becomes r to the power of 1/3. And that is the answer. All right, here is more example like this one. This involves quotient. So the first thing we do is to take care of the numbers. Let's do the numbers. Okay, let's get the numbers, the expression bigger than what it was. Okay, that's more visible. So now what we need to do is we're going to take care of this 4 divided by 2. 4 divided by 2 is 2. So our first number there, the coefficient will be 2. Okay, we got that out. The next thing is we're going to take care of this exponent, 3/4, 5/3. So now let's go back and remember again. If I have x to the power of 7 divided by x to the power of 3, we know that we apply the quotient rule. It will be x to the power of 7 minus 3, which is x to the power of 4. We're going to do exactly the same thing here. So we're going to do 3/4 minus 5/3. All right, so let's see. This is 4 and 3, so the LCD should be 12. And we have to multiply by 3 to get it to 12. Multiply by 4 to get it to 12. So that will be 9 minus 20. So that will be 11, negative 11 over 12. Negative 11 over 12. So it will look like this. Go back to red. So k to the power of negative 11 over 12. Okay, so now, but that is not done. A negative exponent means that we take the reciprocal. So it's going to be 2 over k to the power of 11 over 12. Because of the negative, see, whenever we have a negative like that, it means we take the reciprocal. It comes to the other side. It becomes a denominator. So that is the answer to that. All right, so here is another example that involves even more, a little bit more complicated. So we have power of power. So here is power applied to power, and another power applied to this power. Okay, we're going to do that first. So we'll multiply 3 halves times 1/2. 3 halves, oops, 3 halves. So 3 halves times 1/2. That is this one. All right, so it will be 3 times 1 is 3, 2 times 2 is 4, so 3 over 4. So then we're going to write this one as m to the power of 3 over 4. Okay, that's the first part. Then times, then we do the same thing here. 5 over 4 times 2 over 1. It's better to write this as 2 over 1 to make them match as fractions. 5 times 2 is 10. And then 4 times 1 is 4, which you can reduce to 5. Divide by 2 will be 5. Divided by 2 is 2. 5 over 2. So m to the power of 5 over 2. So now we're going to apply the product property. So whenever you have the same base, you want to combine the base as 1, you add the exponent. So we are going to actually add, we're going to add these exponents together. So let's do the scratch work over there. So we're going to do 3/4 plus 5/2. So we can convert this one to a fourth. So 3/4 plus, this is times 2, 10 over 4 will be 13 over 4. So we're going to have one base. The one base is 13 over 4. And that is the answer to that. Now we're getting to more complicated examples coming up, which is this kind. So it involves power of power, which is this. It involves this power of power, and that involves products. So let's do the power of power first. So we're going to do 3 over 2 times 2. 3 over 2 times 2 is 6 over 2, which is 3. So this p is p to the third, p to the first, and then p to 1/3. Now we can apply the product property, in which we need to add all the exponents together. So it will be 3 plus 1 plus 1/3. All right, that's 4 plus 1/3. And put 1 there, multiply by 3. Multiply by 3. That's 12. It's going to be 12 over 3. So basically, it's just dealing with fraction. 12 over 3 plus 1/3. And 12 thirds plus 1/3 is 13 thirds. 13 thirds. So our P actually is 13 thirds. And that is the answer. So basically, we're just combining, apply the product first, and then combine the power after that. Okay. Next one is the stacked fraction. So what we need to do is to deal with these numbers first. You see, excuse me, that is not stable. All right, we're going to deal with these numbers first. See, 2 and 4 becomes 8. So we're going to multiply those two and get 8. So that'll be 8. And then we're going to deal with the product at the numerator. So it's best that we put 1 over here so that we can add 1 plus 3/4. So if you make them the same denominator, that'll be 1 over 4. That'll be 4 times that. Multiply by 4, multiply by 4. That'll be 4 over 4. Plus 3/4. And that will be 7/4. So the numerator alone is going to be 8, and then P to the power of 7/4. P to the power of 7/4. That pen seems to be too big. I rewrite it as excuse me, 8 P to the power of 7/4 divided by P to the power of 5/4. Now it's a simple step to apply the quotient rule. By subtracting this exponent, we're going to subtract these exponents and get the base to be P. So it will be 8. It will just be 8. 8. And then we'll do the 7/4 plus, minus, because we're subtracting them, minus 5/4. And that will get you to 2/4, which is 1/2. So P to 1/2. Now we get into more complicated example. Well, this is the answer to this. We go to the next example. In this example, you have to deal almost the same thing that you did at the top in example 6, only that the expression is at the denominator. So we need to combine. We need to combine these two. We need to combine these two into one base, and then divide these 3 by 2. And then after that, we're going to do quotient property. So let's do one step at a time. One step at a time. So 3 divided by 2 is just 3 over 2. So we know that 3 over 2. And now let's do this denominator. We're going to combine this. We're going to combine these two with the 5/4 by adding them together. So 2 plus 5/4. And 2 over 1. So multiply by 4. Multiply by 4. That's 8/4 plus 5/4. That's 13/4. So 13/4. So we're going to add 13/4 for the denominator for x one base. So x to the 13/4. And then this is x to the 2/3. Now we're ready to do the quotient property by subtraction. So what we're going to do is we're going to subtract this fraction and this fraction. the one in green. So let's subtract those. Let's do the scratch work over here. So we have 2/3 minus 13/4. Now we need to make them the same denominator. So times 3 times 4 times 4 times 3. So it will be 8/12 minus 39/12. Okay, if you do 39 minus 8, that's 31. Okay, you get 31 equals to 31. So it will be 31/12. But it's going to be a negative because it's subtracting a smaller number from the bigger one. So it's negative 31/12. So our final answer will look like this. It's going to be 3/2. And then the x is at the top with a negative. X to the power of negative 31/12, which we can bring downstairs as 3. We can rewrite it as 3/2 x to 31/12. Because of the negative exponent, see, with the negative exponent, we're able to bring it down. It's a negative exponent right here. Then it comes downstairs. It comes downstairs like down here and loses that negative exponent. And the 3/2 stays the same. So basically, that is the answer for that. And now we're coming up on the last example. This is the last example. We're going to do the power of power first. So all these are going to go inside. It's going to go inside like that and like that. So we're going to do multiplication twice. So 3/2 times 5/3. If you do the multiplication, you will get, this cancel will be 5/2. Okay, so that the first x is 5/2. X to 5/2 times, and then I'll do the multiplication on that one, or the second one, 1/4 times 5/3. That will be 5/12 if you just do multiplication like that. 5/12 divided by x to the 4th. So what we're going to do is to combine these two exponents, combine those by adding them together. So we have 5/2 plus 5/12. And so make this one 12th by multiply by 6. Multiply by 6. So that will give us 30. This is over 12. 30 plus 5 is 35/12. So the numerator is 35/12. Let's go back over here and write x to 35/12 divided by x to the 4th. And we know to subtract them now. We're going to subtract. We're going to subtract this and this. All right, so we do 35/12 minus 4/1. So times 12 times 12. And that will give 35 minus 48. So 35 and that's 48. 3, 13, negative 13. Negative 13/12. So our next answer will be x to the power of negative 13/12, which we can write as, it as 1 over x to the power of 13/12. And so you've seen different configuration. Maybe I have one more example now. I'm not sure. I think there's an example here. And that's it. So basically, the way you work with fractional exponent is the same way you work with whole number exponent. You know, if you're combining them with product property, you just add them together. And if you're dividing them, with power property, you just multiply. Like you just multiply. And you multiply. And if it's a division, you will subtract. Like this one, you will subtract the fractions, and basically it's just a bunch of fraction manipulation. I hope that this helps you a little bit. Thanks for watching.